Welcome back to the shop. Today I wanted to start a build on something that I wanted for the longest time, but I don't want to buy it. And that object is a centering microscope. That's a microscope that you clamp up in the spindle of your milling machine, and it has a right angle eyepiece, and you look into it and you can look down through the center of your spindle on the workpiece. It has a crosshair, so you can pick up marked out lines or edges of workpieces or just everything you can see. There are a lot of manufacturers that build them in very high quality, but they are quite expensive when you buy them new, and even on the used market on Fleabay or something like that, you pay quite a lot of money. And being very ignorant, I was thinking I could build my own. I ordered some microscope optics on eBay. This is a 5 times eyepiece, and this is a 10 times lens. Got screws in here, and this is just a very rough prototype. I took a piece of wren-shaped modeling plastic and I machined out this prototype. The eyepiece goes in here. Down here is a mirror at 45 degrees, like in a periscope. I'm going to add a crosshair that has to go into the eyepiece. We can unscrew the back side here. Then we can place an insert with a wire, with a very fragile wire crosshair in there. But as I said, this is just a prototype, and it has obviously no way to clamp it in a milling machine. I had this set up on the surface plate, and I had it clamped to my height gauge, and I just set it to height and watched through it against a steel rule to see if the magnification is good enough and if the working distance, which is about 8 millimeters, is good enough. And yes, 8 millimeters is, for me, okay. And yeah, this is just proof of concept for me, because I know approximately nothing about optics. In the final design, I don't want to use a mirror. I'm going for a prism. I ordered a optical glass prism that I'm going to use, and it will be machined out of aluminum. Okay, there we go. That's the chunk of aluminum. It's free cutting aluminum with some lead content, so the chips break nice and short. And I'm facing it off on one side. And I break the corner with a file. Now I'm turning down the step to about 25 millimeters in diameter. That's the part of the microscope where the eyepiece will go in. And as you can see, the material produces a very nice short chip. The occasional rat's nest still happens from time to time, like on the end of a cut. Taking a face cut on the end, and we drill out the center with a 19 millimeter stub length drill. Using some water-soluble oil to lubricate the cut. And boring it to final dimension. I'm using one of my shop-made high-speed steel boring bars that I showed in an earlier video. Taking a finishing cut. And the eyepiece fits quite nice. I'm breaking the corners with a scraper. That's the quick and dirty way when you don't want to use a chamfering tool. Now we're over at the milling machine and we mill down the remaining cylindrical part down to be square. And I'm using a 40mm Morse tape of 4 shell end mill that has an integrated shank. This is quite a nice cutter. It's carbide tipped, and back in the day this was a really expensive cutter. I'm pretty sure the carbide goes along the whole length of the cutting edges. Then I roughed out the inside with a 10mm roughing end mill to a depth of about 30mm, and the vacuum cleaner is a great help when you cut such deep cavities. Finishing the sidewalls with a relieved 6mm end mill, very long stick out, but works very well. And first finishing cut, and again taking a light finishing pass to clean up the walls. Next step will be to change the setup. Here you can see the cavity. We rotate it by 90 degrees, set it up in the vise again, and use a rotor broach or a core drill to hog out a hole for the microscope lens. And we change to the Wohlhaupter boring head and machine the hole to final diameter. Taking a roughing cut and the finishing cut. The thread is a M20.3mm thread with a 0.7mm pitch. That's the part finished on the milling machine. Now we set it up for threading. I clamp it in the grinding vise, seat it down, just very lightly tapping it down, and I set the grinding vise on the magnetic chuck in the lathe. I'm using the bull center and the tailstock to align the bore. Just to give me a starting point. Lock it in place. And do an idiot check if the bore is on center. And it was within 2 or 300ths of a millimeter. Now I'm cutting the thread. I have the setup running at about 100 RPM. And was not a problem at all. The microscope lens fits very nicely into the thread. No problem whatsoever. And this part is almost done. Needs only a little deburring, but I'm quite happy. Off camera I machined some additional parts. I made this shank with 10mm diameter, which can go into a collet of the milling machine, and it screws onto the body with 3 screws, and the holes in this flange are oversized, so when I loosen the screws, these 3 guys here, I can move the shank around, and I can use this to center it up, to center my crosshair, which will add to the eyepiece, up with the line of sight, so to center it with the line of the spindle, so when you turn this, it's always in the center of the spindle. For that we need the run-out adjustment. I also made a triangular piece. This is some wrench shape, polyurethane, foam, modeling plastic. I took this material just because it machines very easy and very fast. It's good for prototyping. And I machined it at 45 degree. It screws into the body via the outside through the slot. I had the intention to make it adjustable through the slot, but then I decided just to let it rest against the inside of this housing, and I glued a piece of mirror, which is not the best choice. This is just a shaving mirror that I salvaged and cut down, and this piece is just super glued against this triangular piece, and it's in the line of sight of the eyepiece. And that's pretty much all. Down here we have the thread for the microscope optic or the lens, and here we have our close fit, not very close, for the eyepiece. And that's how it looks now. This is the prototype. Now we can hook it up or set it up in a milling machine and take a look through the eyepiece. We will see if we can get a video image through it. So let's see. Okay, I have a 10mm collet and a spindle. Clamp it up and make sure that you don't turn on the spindle of the machine when you have something like this set up. This might get ugly. And now we have our microscope in the spindle. Okay, we have a more or less clear view through the eyepiece. This is quite hard to set up. And as you can see, when I move the steel scale under the microscope lens, you can see it moving in the eyepiece. And by moving the quill up and down, I can adjust the focus, and I can move the part with the cross slide under the microscope. So far this works quite well. I'm very happy how this came out so far. And the only thing that's left for a centering microscope is of course a crosshair. And then we can use it to pick up features on parts and also use it for measuring if we use the DRO. Okay, I figured out the crosshair. When we take a look through the eyepiece here, you can see that I have a crosshair now. It's out of focus because the camera is focusing on the stuff around it. But when we take the rear lens off and take a look inside, and I need something to point at, you can see the crosshair down in there. And what's the material for the crosshair is 0.1mm copper wire. This is insulated copper wire for winding spools or inductors. The electronic guys have that stuff on hand. And I machined a plastic ring with a groove, and I drilled 4 holes, and I threaded some wire through it so it forms a cross. And I wrapped the wire around the groove I machined into it, and pushed the ring down into the eyepiece and pushed it down and screwed the eyepiece back together and took a look until the wire crosshair was in the focal point of the eyepiece. I hope I don't mess up the terms there, but I think the focal point is the right term for this, and that's about here. I had to push it back and forth a bit until it appeared nice and sharp when I looked through the eyepiece. this works so far quite okay, and as you can see, the wire has a kink in it, and it's out of center by itself. That doesn't matter for this purpose. We're just testing it here. We can screw it back together and go to the machine and take a look through it. Okay, we have our crappy image through the eyepiece again, and you can see that the crosshair is in focus, more or less. And now I'm going to move the quill of the milling machine up and down until I have a sharp or a focused image in the viewfinder of the camera. What we're looking at is again a steel scale. Okay, let's make a better crosshair. We start again with a piece of Delrin, black Delrin, and I'm turning it down to the internal diameter of the eyepiece. And this stuff machine is so beautiful. Taking a finishing cut. And I machined a step on the end so I can clamp it in a collet to drill the cross holes. I machine a groove and I part it off. The groove is to wrap the wire around it later. Parting it off. There it goes. Now I flip it around, clamp it on the smaller diameter. Drill and bore the inside. And that's pretty much all the turning work. Now we go over to the bench. I have my ER25 collet block and I hold the part on the smaller diameter in this block. And on the milling machine and the vise I have set up the stop. And I'm using the edge finder to center on the collet block in the Y direction, touching off on both sides and taking half the distance. That's the center of the collet block. Touching off on the end of the collet block. And I really like these edge finders. They are very, very precise. And now for the drilling, I have PCB drills, carbide, down to 0.3 millimeters. And I use them in plastic and aluminum, but preferably only in plastic. They are very brittle. That's 0.3 millimeters. Very careful when you handle these drills. Most of them break due to clumsiness when handling them. As you can see, it's not very much of a drill there. And now I'm drilling the first hole for the wire crosshair. Just packing. I'm running the drill at 3200 RPM. And we're through. Take the collet block out, flip it around 90 degrees, butt it up against the stop, drill the next one, and so on until I have all 4 holes around it. Now we take the drill and put it carefully back into its case. If you leave that drill out, it will be broken within a few seconds. Not very robust, these little buggers. Back on the lathe and parting off the finished part. Catching it with the scraper and removing the little burr that's left from parting with the same scraper. Now I'm taking some 0.14 square millimeter multi-strand wire and remove the insulation. So I have the bare copper wires exposed, and I cut a bunch of them off. They are 0.08 of a millimeter in diameter, and I use them for the crosshair. I'm threading the wires through the hole using some tweezers and going down into the other hole. I still see good enough to do this work without magnification. And thread the wire through it, pull it through, and wrap it around the outside of the ring into the groove. That's the reason for the groove. And just make something like a knot. And the same thing for the second wire. First securing the first one with a drop of super glue so it doesn't unwind itself. Now we go for the second wire, fiddling it through the hole, pulling it through and going out the other side. And wrapping the wire around and twisting it up, securing it with some super glue, pulling it straight, and there we go. That's the finished crosshair. It goes into the eyepiece, and you need to push it down into the focal point of the first lens of the eyepiece, using a piece of Delrin rod to push it evenly down. There you can see it, and screwing the eyepiece back together like this. And it fits into the microscope, very nice. And now we can test it. Okay, I set the camera up again in front of the microscope eyepiece, and you're looking down onto a piece of steel that I blued up with some blue marker with some edding, and I scribed a cross line into it. And the vertical line, the metallic looking vertical line you see there is the scribe line. And you can see the new crosshair moving across the scribe line, and I can perfectly line it up with the scribed line. And the crosshair shows nice and sharp in the eyepiece, and it's not too thick, it's not too thin. I think that's a pretty good start. I might try to get some thinner wire. The copper wire I picked out of the flexible 0.14 square millimeter wire is 0.09 millimeters in diameter. That's 0.09 of a millimeter. That's about 4/4,000 of an inch, roughly. 3.5 though. something like that. And you can see that the crosshair is nice and crisp, and I like it. And I also aligned the runout when I turned the microscope in the spindle 360 degrees around. The crosshair stays in the center. Not perfectly, but within 1 or 2 hundredths of a millimeter. That's already quite okay for such a rough prototype. I think we have a winner here. This is a pretty simple, very basic prototype with only 2 bought pieces. Only the eyepiece and the microscope lens are bought. They're together about 50 bucks. That's not super cheap, but it's optical stuff, so yeah, costs money. And a broken razor shaving mirror. I'm looking into. I ordered a glass prism, which will be better, but I'm also going to experiment around with the discs out of hard drives. The hard drive discs are finished to a very high surface finish, and they are mirror-like, and there are surface mirror in that fact, because surface is reflective. And I will also try those as a mirror for the eyepiece, and I will redesign it, make it a bit more slim, and I will change the runout adjustment up here, because the oversized holes and knocking the microscope around with copper drift is that's not very cool. So that and apart from that, I'm pretty sure that we will revisit this topic, and it might be interesting for some of you. It's a bit out of the work that I do normally. This is more into optics and real fine into aberrant. This is more into optics and measuring equipment building, and yeah, this is something different. But I like it. What I don't like are webcams and stuff like that are mounted to the machine. They have a horrible picture quality, and you need always a device to show the picture. Yeah, I could use an old smartphone, but nah. Then you have the wiring going off, and nah. This thing is standalone. We will add a small ring light or something like that with some SMD. With some surface mount white LEDs to give us a good lightning around the microscope lens down here, and then we will be good. Thank you all for watching, and see you next time.